Kumusta? My name is Elmer Usman, and today I'll be teaching you how to solve different differential calculus problem involving trigonometric function, logarithmic function, exponential function, and the maxima and minima. So, without further ado, let's get into the video. On this video, we will be focusing to these four topics in differential calculus: the derivative of trigonometric function, derivatives of logarithmic function, derivative of exponential function, and the maxima and minima. And at the end of every topic, we will be having a problem to answer to assess our knowledge if we know something in a particular topic. So let's get started. First is the trigonometric function. But before anything else, in order for us to derive a trigonometric function or an equation, we must first know the 6 formulas in doing that. First, the derivative of sine x is equals to cosine x. The derivative of cosine x is the negative sec. These are the derivative of sine x is equals to cosine x. The derivative of cosine x is equals to negative sine x. The derivative of tangent x is equals to positive secant square x. The derivative of cosecant x is equals to negative cosecant x cotangent x. The derivative of secant x is equals to positive secant x tangent x. And the derivative of cotangent x is equals to negative cosecant squared x. So now that we know the 6 formula in deriving trigonometric function, we can proceed to our equation. So in solving the derivative of trigonometric function, we will be using this formula where the derivative of f g of x is equals to f prime g of x times g prime of x, or simply like f prime as u and then g of x as v, where u prime times v prime is where the formula that we are using. So the equation is something like this. The derivative of cosine raised to 7 times tangent times sine times x raised to 8. So since our function is a composite function, we will be using this formula to answer or to provide an answer in this equation. Y prime is equals to cosine 7 tan sine x raised to 8, and since it is raised to 7, we can put the 7 here and make it as 1, where y prime equals to cos sine tangent sine x raised to 8 all over raised to 7. So now we will be using the power rule. Power rule is something like this: x raised to n minus 1 and n x n minus 1, where n is the exponent to be put here beside the base, and the exponent here would be deducted by 1. So let's proceed. Y prime is equals to 7, since we are using the power rule, we can simply minus 7 or minus 1 to 7 and put the 7 here. 7 cosine tangent sine x raised to 8 over raised to 6. Y prime is equals to the derivative of cosine, where 7 negative sign, copy this tan, copy the sine, and the x raised to 8, and also the exponent. And now let's go to the second term, or to the inside. The derivative of tan is secant squared times copy the sign and the x raised to 8. And now let's proceed to the derivative of this third term. The derivative of sine is cosine. Cosine, copy the fourth term, or the x raised to 8. And finally, the derivative of x raised to 8. X raised to 8. Since it is x raised to 8, we will be using the power rule. 8 minus 1, and put the 8 here. Now, what we'll be doing is to simplify it. To simplify the equation. I am sorry, but the video was cut because I ran out of battery. Anyways, I have already solved the problem, and I'm just going to explain it right now. So where are we? I think we stopped here. So we need to simplify the equation. This 8x raised to 7 should be put here, and all of the equation follows. Since there is negative here, or the negative sign, we can transpose this negative here to eliminate the negative in the inside part of the equation. Next, copy all of this equation. After that, distribute 7 to 8, or the negative 7 to 8, to get the negative 56x raised to 7. And copy sine, tan sine x raised to 8 raised to 6, secant squared sine x raised to 8 cosine x raised to 8. So this will be our answer in the problem. Now, before we proceed to the logarithmic function, we must know that there are two most common type of logarithms, which are the natural log and the common log. Natural logarithm has a base of e, while the common logarithms has a base of 10, or any possible number that could be base of it. Now, in finding or in deriving a logarithm function, we must follow these steps. Step 1. Take the natural logarithm of both sides and apply the properties of logarithms. Step 2. Differentiate both sides and reduce the right side to a single fraction. Third, solve for y prime by multiplying the right side by y. And finally, substitute and simplify the result. First, we need to find the natural log of the equation. We need to find its natural log to the both sides of the equation and apply its properties of logarithms. After doing that, we need to differentiate both sides to reduce and make a fraction out of it. And by doing that, we can find the first derivative of y, or the y prime, and also multiply it by multiplying it to the y or the equation itself. After and to finish, we need to substitute and simplify the result. So let's get started. I have here an equation where we have to find dy with respect to x if y is equals to 7th root of x raised to 3 plus 1 times 6 x raised to 4 plus 8 using the logarithmic differentiation. Now, first to follow the step, we must first take the natural log of to the both side of the equation and apply the property of logarithms. ln y is equals to ln 7 x raised to 3 plus 1 multiplied to 6x4 plus 8. We can also remove this radical sign and make this as an exponent of the equation. ln y is equals to ln x 3 plus 1 6x4 plus 8 raised to the power of 7. We can also use the power rule where 1 raised to 7 can be minus 1 and put 1 over 7 here. ln times x raised to 3 plus 1 times 6x raised to 4 plus 8, and the power or the root will be negative 6, 7. Now, after that, we should distribute ln to each term. 1, 7 ln x cubed plus 1 plus ln 6x4 plus 8 raised to negative 6, 7. Don't forget to put that raised or that root above the equation. Now, in finding the natural log of an equation or of a term, we should use the formula u prime over u. 7 ln is equals to 1 over x cubed plus 1, and the derivative of x cubed, which is the 3x, plus ln 6x raised to 4 plus 8 is equals to 1 all over 6 x4 plus 8, and the derivative of 6x raised to 4 is 24x raised to 3 and raised to negative 6, 7. Now, since we already finished the step 1, now let's proceed to the step 2, which we will going to differentiate both sides to reduce the right side to a single fraction. Y is equals to 1, 7 3x 6x raised to 4 plus 8 plus 24x raised to 3 plus x multiply 2x raised to 3 plus 1 all over the same equation, or the y, x cubed plus 1 times 6x 4 raised to 4 plus 8, and this would be raised to negative 6 over 7. Now that we already differentiate both sides to a single fraction, we can simplify it by distributing each outside term to the inside. 3x times 6x raised to 4 is equals to 18x raised to 5th plus 24x raised to the 4 plus 24x cubed all over x cubed plus 1 times 6x raised to 4 plus 8, and raised to negative 6 over 7. Now let's simplify it. Combine the like term. 1, 7, 18x 5th plus 24x 4th plus 24x 3 plus 24x all over x cubed plus 1 times 6x raised to 4 plus 8, and raised to negative 6 over 7. We can finally go to the step 3, which is to solve for y, or the y prime, by multiplying the right side by y. Y prime over y is equals to 1 over 7 18x 5th plus 24x 4 plus 24x cubed plus 24x over x cubed plus 1 6x 4 plus 8. It is called the process of rationalizing. Y prime over y is equals to 1 over 7 18x 5th raised to the 5th plus 24x raised to the 4 plus 24x raised to the 3 plus 24x all over x cubed plus 1 times 6x 4 plus 8 multiplied to x cubed plus 1 6x 4 plus 8 and 1 7 and to 1 over 7. Since we have here an equation, we should now move forward to the fourth step, which is to simplify the result. We can see that all of them are divisible by 6, so that let us put 6x outside and 6x 3x raised to 4 plus 4x raised to 3 plus 4x raised to 2 plus 4x. 4, since it is only 1x times raised to negative 6 to 7 times the y, which is the x cubed plus 1, 6x4 plus 8, raised to 17. Next, y prime over y is equals to 17 times 6x times 3x4 plus 4x cubed plus 4x squared plus 4 raised to negative 6 over 7 multiplied to x cubed plus 1. Since it is an equation, we can use the power rule to reduce the term 17. We can put 17 here. X cubed plus 1 times 6x raised to 4 plus 8. 17 minus 1 is equals to negative 6 over 7. Now y prime over y is equals to, what we're going to do is to put 6 here. 6 over 7. 6. Since 6 is not here anymore, we can put here x. 3x raised to 4 plus 4x raised to cube plus 4x squared plus 4 raised to 6 over 7 multiplied to 1 over 7 x cubed plus 1 times 6x raised to 4 plus 8 raised to negative 6 over 7. So this is the final answer in our problem number 2. Now let's proceed to the derivative of exponential function. Derivative of exponential function. We have a problem here. Our problem would be this one. Y is equals to 4 raised to 5x squared over 4 raised to x cubed minus 4. Have you noticed anything? Its base are the same. So what we're going to do is to use the formula x raised to a, where x raised to a over x raised to b is equals to x a minus b. So let's start. Y is equals to 4 as the base and 5 raised to x squared, 5x squared minus x squared minus 4. After that, we have to simplify it. We have to distribute this negative sign to the inside portion of the term. Y is equals to 4, 5x squared, negative times x squared equals to negative x squared, negative times negative 4 is equals to positive 4. Now, what we're going to do is simplify it. Y is equals to 4 raise 5 minus 1 is equals to 4x cubed plus 4. Now, since we have only one term left, what we're going to use is the formula of u and v. Let u is equals to 4x raised to 2 plus 4 and v is the base. To find the derivative of it, we need to use the formula. The derivative of y with respect to x is equals to the v raised to u times u prime, or use the derivative of y with respect of x is equals to derivative of y with respect of u times the derivative of u with respect to x. After that, we need to substitute it. The v is the base, where 4 u and the u prime, or the derivative of u, let us first put the u, which is the 4x squared plus 4, and find its derivative. For u, derivative of u is 2x plus 4. For u, 4 times 2 is equals to 8x, or we need to distribute this one here, plus 4 is equals to, u is the 4x squared plus 4 times the 8x plus 4. We can put 8x here plus 4, or interchange it, multiplied to 4 raised to 4x squared plus 4. Now, it's the final answer. Here's our answer. The answer for the derivative exponential function of y is equals to 4 raised to 5x squared over 4 raised to x squared minus 4. Now, let's proceed to the maxima and minima. In solving maxima and minima, we must follow these steps. Now we have this problem here. A wire of 32 feet long has to be formed into a rectangle. What dimension should the rectangle have to maximize? Or let's draw a wire, or a 32 feet long wire. Should have a representation of a rectangle here, where the both sides are equal to x and y. Since the area of a triangle or the rectangle is equals to length times width, length and width should be represented by x and y. Now to find y, we must first use the formula of the perimeter. The formula of the perimeter is P is equals to 2 times the length and the width. Let's say the perimeter would be the 32 feet long wire times 2 x y. What we'll be doing is to divide both sides by 2. Fill out 2. 32 divided by 2 is equals to 16 x y. Now to find y, we put y here, and 16 would be 16 minus x. What we'll be doing is to find the x. Area is equals to x, and the y, which is the 16 minus x, we have to distribute this first. X to 16 and x to x. X to 16 is equals to 16x. X times x is equals to x squared. Now, the derivative, find the derivative of those. 16x, the derivative of it is 16 minus the derivative of x squared is 2x. Now equate it to 0. To eliminate the 2, let us put or divide both sides to 2. 2x is equals to 16 divided 2 is equals to cancel out this 2, and 16 divided by 2, x is equals to 18. Now we're going back to our y. Y is equals to 16 minus what is our x? It would be 8. Y is equals to 16 minus 8. Our y is still the same. It's 8. Actually, it's not actually part of our steps, but in order for it is not actually part of our steps, but if we want to check if answer is correct, if it maximize the rectangle, we can also use the second derivative test, where a double prime, which is 16 minus 2x, to the equation or to the problem that we have, which is a wire of 32 feet long has to be found into a rectangle. What dimension should the rectangle have to maximize? The rectangle should have an 8 by 8 side or dimension to maximize, which is negative 2, to maximize a rectangle, so it would form a square. That's all, I think. Just a recap. That's all, and I thank you for listening and watching to this short video about differential. Thank you. And I think that's all. Thank you for listening and watching to this short video about differential calculus. If you have question, as what I have said earlier, you can drop it to the comment box, and if I have time to answer it, I would gladly answer your question. That much. Thank you. Have a nice day. Once again, I am Elman Osman. I am a first year civil engineering student at Once again, it's me, Elman Osman, and I am a first year student of Bachelor of Science of Civil Engineering in University of Southern Mindanao. Have a nice day.